Hello everyone. Today I want to talk about a circuit analysis technique called mesh analysis. And it's actually very similar to nodal analysis, only instead of repeatedly applying Kirchhoff's current law, we apply Kirchhoff's voltage law over and over again to develop a system of equations and then solve for your unknowns. Typically, mesh analysis works well for when you have a circuit that has a lot of windows in it and voltage sources. And when you see that, generally that's a good indication that mesh analysis would make your life easier. So, for example, like what do I mean by windows? Another name we call them is meshes. So, for example, let's say you had a circuit like this. Notice how this circuit can be divided into nice, neat little windows, basically. So here's a window, here's a window, here's a window, here's a window, and then here's a funny looking window, but it's a window nonetheless. If you can divide your circuit up like that, you can apply mesh analysis. So what I'm going to do is I'm going to work through an example, and I think basically introduce the technique step by step as we're working through our example. But know that essentially each window we call a mesh of the circuit. So I'll go ahead now and delete this and start with my example. We'll call this R1, R2, R4, VS2, R3, and R5, and this VS1. So notice this is a nice circuit with nice little windows. And so let's go ahead and use mesh analysis to be able to solve for all the voltages and all the currents in the circuit. So step one of mesh analysis is to identify all meshes. So basically all the windows. So this is a mesh, this is a mesh, and this is a mesh. And we'll go ahead and label them. Let's call this one, let's say this is mesh 1, this is mesh 2, this is mesh 3. Actually, let me go ahead and I want to do that in a different color so it stands out. Mesh 1, mesh 2, mesh 3. Okay, simple enough. Step 2, label mesh currents. So I will explain a little bit more about how mesh currents work, because initially it might be a little bit confusing physically on what it is representing. But for now, what you do is you define a circulating current, basically, that goes around the mesh. So a current that goes around this window, a current that goes around this window, and a current that goes around this window. So for example, we could say that the current here, this is our mesh current I1. This here can be our mesh current I3. And this here, all around this loop here, can be our mesh current I2. Now, you might be a little bit confused here because you're like, wait a minute, are we literally drawing two currents that are like opposing one another through the resistor? And I know that's probably confusing. No, physically that's not possible. That's not what is happening, where there's like literally two different currents that are like flowing through the resistor simultaneously. But rather, this is like a mathematical tool that we're employing. So um, I think it'll become more clear how these mesh currents work when we actually work through the example step by step. So we've done that. We've labeled our mesh currents. And then 3 is apply KVL to each mesh. So with each loop here, we go around and we apply KVL and come up with 3 equations. So let's go ahead and do that. Let's go ahead and do mesh 1. And actually, while we're at it, let's go ahead and also define our voltages across our resistors. So I could say this is plus and minus V4. I'll call this plus and minus V1, plus and minus V2, plus and minus V3, and then plus and minus V5. And again, I just arbitrarily assigned what orientation it is, because as long as I'm consistent in my math, it shouldn't matter. So let's go ahead and do that. Mesh 1. Let's go around the loop. All right, first sign that we hit is the sign of the voltage in our summation, right? We're summing all these voltages and it should be equal to 0. So we hit this first sign, that's a plus sign. So V4 plus V4. V4 plus, oh, we hit another plus sign, so plus V2 and then we go around and hit plus here, plus VS2. It's equal to 0. All right, now mesh 2. We'll go around the loop. We hit plus V1 here. Then we hit a minus sign here, so it's minus VS1. And then we go around and we hit a minus sign over there, so minus V3. And then we continue going this way and we hit a minus V2. And that is all equal to 0. Now one last one, mesh 3. So starting here, we hit a minus there, minus VS2. Plus the voltage V3 across this resistor, and we hit the plus sign there, so plus V3. And then we go around and we hit another plus sign there, plus V5. And that's all equal to 0. So we've applied KVL to each mesh. The next step then, step 4, is apply Ohm's law to each KVL equation. So essentially, we have all these voltages here, but what we want to do is we want to express them in terms of the mesh currents using Ohm's law and the resistances. So let's go ahead and do that for our resistors. Let's start with R1 or V1. We can say that V1 is equal to the current flowing through it times R1. What is the current? The current is I2, this mesh current I2. So I2 times R1. Or I'm sorry, R1 times I2. I mixed that up. All right. Now let's do, I'm going to do these two other resistors after I do all the other ones because they're a little more tricky. But let's go ahead and do this one, R4. So V4 is equal to the current through this resistor times R4. So it's I1 times R4. Now, let's go ahead and do our V5 here. Here we have a mesh current I3 times R5 equals V5. So V5 equals R5 times R3. Now, here's where you have to be a little bit careful here. So let's try and find V2 here. So V2 is going to be equal to the current in this direction flowing through the resistor times R2. So I'm going to call that, I'm just going to say V2 is equal to IR2, the current flowing in it, times R2. Now the question is though, how do you express the current in the resistor IR2 in terms of your mesh currents? And you express it in the following way. So here I'm just going to draw R2 isolated here. And it has a certain current flowing through it, right? IR2. But then we also have these mesh currents that we've drawn. We've got I1 and I2, so I1 going this way and I2 going the other way, right? According to how we've drawn I1 and I2. And the question is, how can we express the current flowing in this direction through the resistor in terms of our mesh currents I2 and I1? And the answer is that that current is going to be equal to I1 minus I2. If we wanted the current going in the opposite direction through the resistor, then it would be I2 minus I1. But in this case, we do I1 minus I2 for this direction. Now, I know what you're probably thinking is, that's kind of weird. Like, what are we saying? There's literally like two currents simultaneously flowing through the resistor? And the answer is no, there isn't. It's basically just a mathematical sort of tool for figuring out the currents in the resistor. You kind of imagine. Oh, give me just a second. Actually, I need to plug my laptop in. There we go. Battery indicator went on. All right. So basically, um, you express this current here. Even though physically it's not true that you have two currents simultaneously flowing through the resistor, um, mesh analysis is essentially just like it's like a mathematical tool, and you think about it in terms of you can almost think of it as like the two currents fighting against each other, and the actual current that's flowing through it is the difference between the two. So um, it's that's kind of it's basically a mathematical tool for figuring out or expressing the current through the resistor in terms of your mesh currents. So that's I1 minus I2. So that means that your V2 is going to be equal to I1 minus I2, just plugging that in, times R2. And then in a similar manner, we can express the voltage V3. So again, we've got, so V3 is going to be equal to the current through that resistor in this direction, which is going to be I3 minus I2. Times R3. And that gives me, or I'm sorry, that should be, no, actually, no, that's correct. Never mind. Times R3. And so that gives me the voltage across R3. So now what you can then do is you take all these voltages values and you plug them into your set of KVL equations that you've developed. And then once you do that, you can then, as your fifth step, solve for the mesh currents, your I1, I2, and I3. We have three equations, three unknowns, and then based on that, then you can figure out all the other voltages and currents in the circuit. So that pretty much summarizes the mesh analysis technique. In the next video, I will change up this example a little bit and yeah, do another mesh analysis example. Thanks for watching. I hope this was helpful, and I'll see you in the next video. Hello everybody, thanks for watching. If you found this content helpful, would you please consider liking and subscribing to the channel? That will help other people find it. And if you won't do it for me, will you do it for my cat, Muon? Named after my favorite subatomic particle, by the way. So, she will be very, very upset if you do not like and subscribe. So please, don't disappoint. How could you say no to this cuteness?